So before we get into the talk, let me just tell you a little bit about myself. I'm Phil Naparalski. You can just call me Phil. And I'm a program manager on the Windows ecosystem team. So what that actually means is I work with external partners, people like you, who are using DirectX in their application, and I try to help them along technically. So a lot of this talk, and I said this in my other talk, but a lot of this talk is a culmination of the things I've noticed that have been pain points for partners. So if you ever get into DirectX with your Windows Store app, hopefully this will help you out and get over those pain points. So kind of what this talk is going to cover is it's going to cover things like how you can transition from, say, DirectX with the desktop to the Windows Store, and what's changed, what's been updated. And then it's kind of going to happen in two parts. So the first part is I'm going to talk, and then the second part is I'm going to pass the torch to someone from AccuWeather, Stephen Kiefer from AccuWeather, who's going to kind of give his take on how they utilize this knowledge. So let's just jump into it. I'm first going to start with kind of what's changed from the desktop, what we've updated with Windows 8. But before I get into that, I want to kind of give you a little bit of a history lesson. So with every version of Windows since XP, we've worked closely with hardware vendors to push the boundary of graphics. And we've gotten new features like tessellation, geometry shaders. And because there's new hardware to go along with that, there's also we also have to unlock that functionality with new APIs. So you have the DirectX 9 API all the way up to 11. And then the question becomes, with all this wide array of hardware in the Windows 8 ecosystem, the question then becomes, how do you design your software for all this hardware? So that question is going to ripple throughout this talk. And I'm going to demonstrate that it's actually not that bad. It's actually quite easy. So with Windows 8, this history lesson hasn't changed. We now have the DirectX 11.1 API. The majority of the investments that have gone into this API have been things like increasing speed and performance, because now we have to support all these ARM devices, all these system-on-a-chip devices, these power-efficient machines. So on top of that, we've made integration of all the graphics technologies that come with DirectX much easier to use together. So if you want to use Direct3D with Direct2D, we make that a lot easier with your Windows Store app. And then, of course, with DirectX 11, we have tessellation, and with 11.1, now you even have the ability to use active stereoscopic 3D. Now, in the past, for stereoscopic 3D, you've had to use third-party tools like NVIDIA Solution and whatnot. Now you can just use it as part of the swap chain. And then the caveat here is, well, because we have these ARM devices, these system-on-chip devices, Clover Trail, etc., you have to take in considerations what are the features that are on those particular devices. So one of the biggest questions that I get asked from external partners is, where is the DirectX SDK? Well, it still exists as an external thing. It's on MSDN. But then they look on MSDN and they find that June 2010 is the latest one. There's a reason for that. The DirectX SDK is no longer its own entity. It's now included in what's called the Windows SDK. Now what that means for you guys as developers is that when you actually want to go and use DirectX, when you want to start writing DirectX code, well, now you can just include the right libraries, include the right headers, and you're good to go. You don't have to go out and find this external SDK. The caveat here, some of the things that are in the Windows SDK, some of the things that are in the DirectX SDK do not appear in the Windows SDK. Things like runtime shader compilation, things like the effects library, if you've ever used that. However, there are alternatives to that. Well, now the shaders are compiled at build time for you. You get the bytecode at build time. And what that means is, did my mic just turn off? You're good? Okay, I'm good. What that means is that the user is going to get a better experience in their loading as your app is loading. So there's less time being taken on the loading screen for compiling shaders. Now it gets the bytecode and it goes from there. What about the effects library? Well, there's all kinds of things that you can utilize that are third-party. The DirectX toolkit is one of them. But something that's in Visual Studio 2012 today is this Visual Shader Designer. It's this drag-and-drop interface, so maybe you don't like that. Maybe you know HLSL and you just want to write that. But I encourage you to try out this Visual Shader Designer as an alternative to the effects library. So going back to that question, how do you design for that wide array of hardware that's in the ecosystem today? Well, with the DirectX, I believe back in DirectX 10 and now in DirectX 11.1, we have one API that drives everything. And with the DirectX API, we've introduced this notion of feature level. So what that means for you guys as developers, if you want to target the wide array of machines out there, you can target feature level 9. Okay? But then you can build up from there to make your app stand out. So with feature level 9, you have all the functionality that you need to make a great DirectX app. You have things like the vertex shader, the pixel shaders, all that good stuff. And then you can use all these features to get your app working. But then when you want to differentiate, you want to make your app stand out just a little bit more on higher-end hardware, then you can use things like Geometry Shader and feature level 10 machines. And then finally, maybe you're writing a tessellation tech demo or a game that uses tessellation. You can certainly use that with feature level 11. So as I'm working with partners, there's a lot of things that I get asked that pertain to feature level. So your Surface device that you just got, for those in the audience, that's feature level 9.1. So the question then becomes, okay, I've created this great 3D model in Maya, 3D Studio Max, or Blender. Now how do I make that work with the Surface? Well, the Surface is, because it's this great integrated tablet-like device, it has some limitations because we can't fit this humongous graphics card in there. And so you have to kind of tone down the number of primitives in your model. And you have to do things like those HD textures. Well, you can still use really high-quality textures, but now you have to tone those down a little bit too. So all launch ARM devices, all the devices that are out there today that are ARM, those are feature levels 9.1 and 9.3. So these are some things you guys should be thinking about when using DirectX to get that breadth with your app. So now I just want to jump right into a sample that you can find on MSDN, and it's called the Sprite sample. And so what I'd like to show you first is, well, what is the sample? This sample essentially is a recreation of the Sprite batch functionality that's in XNA. And what it does is, if you're on a feature level 9.93 or a feature level 10 machine, it will make this Sprite sample run faster and have more particles and have more asteroids because it's able to use things like instancing and geometry shaders. So I'm on a feature level 10 laptop. I'm demoing on a feature level 10 laptop. So everything that you see here is drawn using instancing and geometry shaders. Now, what does that actually mean? Well, what's even a shader? Let me explain that. So a shader is something that's executed, code you write that's executed on the graphics card. And the first part of the pipeline is the vertex shader. Okay? And the vertex shader gets passed in input. It gets passed in vertex data. Okay? So each of these asteroids are actually two triangles. So you put two triangles together, you get a rectangle. Okay? So there's all these vertices going into the vertex shader at once, and it's doing this graphics operation in parallel. Okay? But with instancing, you only have to pass in one pair of triangles, and then just the offset and everything after that. So you're removing some redundant data by using instancing. And then with geometry shaders, you can actually just pass in a point to the vertex shader. And then what the geometry shader is then doing is breaking up, it's creating two triangles based off that one point. So this demo has two features. It has that feature level thing that I'm going to show the code for. And then it also has another thing where it dynamically changes the number of particles on the screen based on the performance. So you'll see as the particles are bouncing across on the screen, they're fading away. So that's one feature that you can use to make sure your app is still running fast. So let me go into the code a little bit. So I've been talking about feature levels, and I just want to show you how ingrained feature levels is even into Visual Studio. So over here, this sample comes with 5 shaders. Why are there 5 shaders? Well, you need a different shader to represent instancing. You need a different shader to represent the geometry shaders. But if you right-click one of the shaders and you go to its properties, what you can see in the HLSL compiler area is you can see something that's called Shader Model Level 4.1. So if you want to use Shader Model 2 or Shader Model 3, I mean, I guess you can. But if you want to utilize some features in Shader Model 4 that will run on any machine in the Windows 8 ecosystem, this is the shader model to use. And then you can even see Shader Model 9.3 that you could use for instancing. So let me show you that. So here I'll go to my instancing vertex shader, go to its properties, and you'll see it's using Shader Model Level 9.3. But then beyond that, when I'm getting to the geometry shader portion, it has to go to full Shader Model 4. And because that requires feature level 10, that's why that happens. That's why that's set that way. So now what I want to show you is I've placed some breakpoints in this code so you can see kind of what's happening that's related to feature levels and some things that are important. So the first breakpoint I have set is to this API called D3D11 create device. Why does it start with D3D11? Because that's the API that you're using, the DirectX 11 API. And then if I hover over M feature level, what this function call actually is telling me, it's telling me what is the feature level of the hardware that my app is running on. So you don't, and then up here, you can also set what feature levels you want your app to be supported. So you have this array, and if I want to not support feature level 9.1, you just delete that, okay? But I'll leave it in for now. And then that gets passed to the D3D11 create device call right here, and then what gets spit back is the highest feature level that the machine supports. So then later in the code, because my laptop is feature level 10, I have this check. If the feature level is greater than 10, well, you know what? I'm going to use the geometry shader. I'm going to use geometry shaders throughout the rest of my app. And then, because I'm using this geometry shader technique, I have to load in my corresponding shaders to go with that. So here I'm setting what are the inputs to the vertex shader, what goes into the graphics pipeline. Well, I have those transformation data that I talked about with instancing. But then down here, I have a geometry shader that I'm loading that's going to take that point and create 2 triangles from it. And then finally, boom. So a few slides ago, I posed the question, how do you design for all of this variety of hardware in the ecosystem? Well, there's this cool thing called the DirectX control panel that you can use to emulate lower feature levels. So if you're on the start screen and you just type dxcpl.exe, the DirectX control panel, and bring that up, go ahead and click yes. What you can do here is add simple sprites, the simple sprite sample or whatever you want, to a list that says, okay, when that process runs, I will use a lower feature level. I'll try and emulate lower feature levels. So here I'll go to edit list and I'll type in simple sprites.exe. Why do I type simple sprites.exe? Well, that's the name of the project, and the default executable name is just the name of the project.exe. And you can check the project properties for that. Or click add. yes, okay. And then down here, you'll see this drop-down box. Right next to it, it says feature level limit. What feature level do I want to emulate? Let's try 9.1. And then I'll click this checkbox that says disable feature level upgrade. What's that mean? Well, if I try to do something like instancing on feature level 9.1, it will actually throw an exception. The operating system will throw an exception, and if you don't catch that, then your app will be terminated. So let me apply that, and let me just show you how this works. So here I have my D3D11 create device API call. And now if I hover over M feature level, I know it's a little small and maybe a little hard to see, but you'll notice that it's now using feature level 9.1. And then that ripples throughout my code here. It limits the number of particles because on lower end machines you want to have maybe less particles so it runs faster. And then it's going to use this other technique called replication, where you have all this redundant data going in, but the key here is that it works. And then if we continue here, now I'm loading the corresponding shader that goes with that feature level. And boom. Now you'll notice there's less asteroids, there's less particles. Now why is that? Well, because I'm emulating feature level 9.1, the hardware is not being clocked down or anything like that. It's just emulating the feature set. But I also know that on lower end machines there's maybe a little more performance considerations, so I'm limiting the particles that are on the screen. So now if we up this to feature level 9.3 back here in the DirectX control panel, now it's using instancing. And we'll just click through here. And you'll notice, okay, now because we're using instancing, I'm able to render more things on the screen because that's a faster way of going about things. And well, that's how that works. Okay. So I just showed you an example that uses feature levels in an interesting way. What was the point of that sample? Well, it uses this replication technique on feature level 9.1. It uses instancing on 9.3, but why? Who cares? Well, the point here is you can get your app, or in this case the sample, you can get your app working on the wide array of hardware that is out there today by doing things like, taking into consideration the limitations that I talked about. But then, if you really want your app to stand out, you can do higher level things like using geometry shaders and instancing, so you can have more particles on the screen at once. So the key here is start with 9.1, okay, get it working, and then build up from there and make it really stand out. So I just want to review a few things that I talked about with the sample, some code that you can go into. So yeah, the message here, target feature level 9.1 to start with, and scale up from there. So with the sprite sample, like I mentioned, started with replication, added instancing and geometry shaders from there. And why would you care about differentiating with higher feature levels? Well, because we know from talking to people, from studies that have been done, that the average person has more than one machine. Now, you guys all have a Surface, all of those you attendees, but you also have your work laptop, you have your home laptop probably, and maybe you even have a high-end gaming machine. So why would you just target feature level 9.1? Well, first get the breadth, okay, and then now when I play your game or I use your app on my high-end desktop machine, now I get cool things like tessellation and all these other great things. However, I realize that not all of you want to write something that's going to run on feature level 9.1. I encourage you to, but maybe you're doing something like a tessellation tech demo, something like that. And you can only target feature level 11. If you must do that, make sure you tell the user. So, as part of store policy even, you have to have in your description and in when your app launches that you have to tell the user what the feature level is if their machine does not support it. And if you want to develop an app for ARM, you have to target the wide array of devices, because most ARM devices that are in the Windows ecosystem today are feature level 9.1. So it only makes sense that you should support that. And like I mentioned, if you target a higher feature level, make sure you tell the user in the description of your app and as they launch the app. If you don't check the feature level, but you require something higher, again, the operating system might terminate your app. And so in the sprite sample, I showed you that array that goes into the D through D11 create device call. That's right here. So again, if you want to support just feature level 11 and up, you can do that just by removing the feature levels that you don't want to support. And here's that API call that I showed you from the sprite sample. And this is where you can get the D through D device, the context, and the feature levels that are supported on your machine. Yeah, and like I showed you in the sprite sample, you can get the feature level either from that API call, or you can do that this way, and then you can simply check the feature level like so. So switching gears a little bit for one slide, I talked about how you can how feature levels are even ingrained in Visual Studio with the shaders a little bit, with the shader models. Well, there's other investments we've made with shaders, things like syntax highlighting. And now you have build time compilation of your shaders. And what actually happens at build time when you're using FXC, when your shaders are compiled to bytecode, when create pixel shader is called, that method call, that will actually convert the bytecode into the instruction set that the driver understands. So here you have this high-level HLSL code, and then below that you have the bytecode, which is what gets, you get a CSO object at build time. And then at runtime, now it's converting this bytecode to something even lower level than that, this instruction set that the video card will then understand. So now what are some recommendations I can give for testing and debugging? Well, I already showed you the DirectX control panel. You can use that. And of course, you guys know the obvious one. Make sure you're not doing anything silly. Review your shader code. But beyond that, let's say you're writing this great app. Maybe it's a weather app, I don't know, and you get some weird rendering artifacts in your app. How are you going to go about debugging for that? Well, make sure, one way you can determine if it's a hardware-specific thing is using Warp. Now, what Warp does is it renders, instead of using the graphics card, it will render things on the CPU. So it's a software rasterizer. And if it doesn't work with Warp, then your code's bad. But there are also some tools that you can utilize in Visual Studio to help with this. The Visual Studio Graphics Debugging tool is one thing you can utilize. And if you guys had a chance to check out Rong Lu's talk, that was a great resource. I believe she mentioned this a little bit in her talk. But what this actually allows you to do is now if you're rendering something and you get this weird gray square or something should be there, but you're getting a gray square. Well, now you can click that pixel, one of the pixels inside the gray square, and it'll show you everything in the graphics pipeline. And it'll help you kind of debug where that error is actually occurring, what shader it's in, potentially. And then there's also this little thing called remote debugging. Now, what's remote debugging? Well, a lot of you have a Surface now who are in the audience, and other machines that you want to test on, but you maybe only have one Visual Studio license, one developer machine. Well, what you can actually do is utilize Visual Studio on that one machine and then set up a remote debugging client on your other machines. And then, just using this tool, you can have it run on one of those machines at a time, and then you can walk through the code as it's running, as if it was debugging on the local machine. So this is a great feature to catch some of your errors as well. And so now, it's great to talk about feature levels, but I haven't really touched on the title, how easy it really is. how easy using DirectX really is. So I want to introduce Stephen Kiefer from AccuWeather. He's a programmer on AccuWeather, and he's going to tell you a little bit about how they use graphics to stand out and the experience there. So, Stephen?
Thanks, Phil. How's everybody doing with this beautiful weather outside? This is not what I expected when I came here. Working at AccuWeather, we started on the Windows 8 application sometime in the early spring. And we have done applications before. We built a pretty large client basis, but there's only certain ways you can present the data. You can lay it out, you can make it horizontal, vertically, but it's still the same data. We wanted to do something to wow the audience. We wanted to do something to show the Windows 8 experience with Direct3D. Doing so, a couple years back, we had tried to use videos to do animations. This worked, but the file sizes were huge, bad for downloads. We had tried to play around with Windows Phone using XAML animations. This was getting us closer. Performance wasn't quite what we needed, though. We needed something that would be smooth, that would be fast, and stable. Reading up on Windows 8, we read about a Direct3D and XAML interoperability. This sounded exactly like what we needed it to do. This would give us access to the hardware layer. But we could also present XAML elements on top of it. In doing so, we wanted to reach out to a developing partner of ours that we had used before, Vectorform. They helped us out on many other projects, and when we approached them, they agreed. They loved the idea. They were excited. Immediately, we started talking about it, and we knew that there was going to be challenges along the way, though. As Phil had talked about, we were going to have to support feature levels 9.1, 9.3, 10, 11, all of them. We were going to have to support legacy machines because Windows 8 runs on every machine. But at AccuWeather, we wanted to run on every machine as well. We didn't want to let anything out. So how are we going to accomplish this? That was one of the challenges that we incurred. Another challenge that we knew that we were going to have was how are we going to get all this weather data to the background renderer? C++ and C#, if anybody's ever tried it before, normally doesn't play very well. Creating a fully dynamic scene, this sounds awesome. This would be exactly what we want to do. We don't want any two scenes to be identical. Every time it renders, every time it starts, something new. You're going to see, you may notice a cloud in a different place. It may spawn up in multiple layers. The biggest challenge that we are going to incur, small developer community. Everybody in this room is a developer. Everybody's had a problem before. When you run into a problem, you reach out for help. There was very few resources at this point in time for us to reach out to. Working with Vectorform, Philip Skakum, got to know him very well. He is as passionate about code as I am. There would be times when we'd be working on issues 4 o'clock in the morning, and he was over in Europe sometimes, and I would be getting emails that I know was his 4 a.m. This was just the passion that I knew we had. To overcome these challenges, Philip put together a proof of concept app that showed that you could actually render the Direct3D background with XAML over top of it. This was our first milestone. We knew we could do this. One of the key features of doing so is the swap chain. Everybody's created a swap chain before. It's a standard. Now we had a swap chain for composition. This was the key to everything. This allowed us to have the two of them play nicely. Third thing, like I talked about with the videos, that's awesome, but one video fading into another, that's not easy to do. How are we going to go from a sunny day to a clear night and make it smooth? These were some of the challenges that we were going to have to face. The blend states were very key. They allowed us to take control of every pixel between sunny and clear and fade one into another. So now we had that smooth transition that you've seen in earlier. Some of the other challenges and features that we added, they were huge. We added in the ability to do instancing. We could do one A light shower, like you guys experienced here. I did not know this was a light shower. That lasted 2.5 days. For me, a light shower ends after 25 minutes. But using instancing on the higher levels, as Phil had mentioned, we could go from 1 pixel to upwards of 1,000. But how are we going to support the 9.1 machines? There was a technique that we used that had a scrolling texture. It looked identical. It covered the same look and feel, but didn't lend to scaling. What if it was the biggest storm ever, like the East Coast is seeing? We could actually ramp that up to show 10,000 particles flying instead of the normal 1,000 with one draw call. No performance hit at all. The instance buffer, as you see, it's pretty straightforward. If anybody's ever played around with it, it's very straightforward and it works. One draw call, 10,000 particles, you can see the difference. The very cool thing is, when you're doing it the way we did with the particle system, when it starts to rain or starts to snow, they all don't come down at once. One comes down, then another, and it slowly turns into that horrible night of snow that some people up here apparently love. I'm not a snow fan either. I like 75-degree weather. So I guess in closing, the biggest thing that we learned from taking away from this, Windows 8 and DirectX, they play excellent together. We achieved the goal that we wanted to hit. We were able to work in parallel. One would work on the user interface, one would work on the renderer. We could share code back and forth across the country, and we never hit a hiccup because they played so nice together. This was very important because, like I said, C++ and C#, they generally don't play too well unless you like headaches. The last thing is, and I've been saying this for a while now, I'm a big DirectX fan, Direct3D. Now we can actually use Direct3D inside of an application. You can use all these other shaders, all these vast universe of shaders that are created for post-processing and everything else. You can now do all of those inside your application. It's just, how are we going to do it? How can we achieve more out of a standard application? That's why I've been saying DirectX is going to let you take your application into the future. And I honestly believe that. I think there's some people that are going to make some excellent applications, and I hope so. That's all I have to say. Thanks, Phil.
Awesome. Thank you very much, Stephen Kiefer. That's a great example of how you can really bring your app into the future, like he said. But a couple of things I talk about, just to wrap up, make sure you turn your mic off.
Oh.
Just to wrap up, a couple of the things I talked about, target feature level 9.1 to start with. Make sure it works on the wide array of machines. But then scale up from there. What can you do? Can you add more snow particles to the screen? Can you add more rain particles to the screen to really make it stand out on higher end machines? So the key message here, when designing your app, consider feature levels. And I encourage you to check out these resources. And I'm a little early, so we have plenty of time for Q&A. So bring it on. Question? And I'll repeat it.
Sure. If we're looking to share DirectX code from our desktop application to a Windows RT app, what kind of problems are we going to run into? Like I mentioned, the C++ CX is going to bleed, and how far does it bleed?
Right. So the question was, essentially, how do I share my code with the desktop? Essentially, what you have to do is some if defines in your code. So if it's a Windows Store application, do this thing. If it's not, do this other thing. But other than the fundamental things like C++ CX, that's generally not an issue. And I encourage you to check out Chuck Walburn's blog. Maybe you've heard of it. He does a lot of stuff on this. So Chuck Walburn, and I can follow up online if you need that link. Any other questions? Yeah, right here.
Would it be possible to actually write for the highest level, and then if the hardware is lacking, just use software rendering instead?
Great question. So he asked, can't you just start with the highest level and then use software rasterizing? Well, you can if you're okay with a slideshow. Okay. So the software rasterizer is very optimized. It's great for you know, maybe casual games. But if you want to do something like Tessellation and maybe a AAA level game, it is still not powerful enough because just the CPU is not built for that. So that's kind of my recommendation for you. Next question.
CPL.exe, does it work for all processes, not just WinRT, but even the desktop processes too?
I believe it works for all processes, yes. And then did you have a follow-up question over here?
Yeah, my follow-up question was that, you know, if you go for the highest level, then of course it will run fine if you have good hardware.
Yeah.
But if you have bad hardware, is it, you know, is it going to be any different to sort of is it going to be possible to replace what's lacking in hardware with software and use whatever hardware is there?
So there's one. Let me try and repeat the question. So, can you just replace the hardware? Is that kind of your question on lower-end machines?
Now, what I'm saying is that if you write for a high-level machine, then things will run fine there.
Perfect.
Then,
Yeah.
But then we can say if the machine actually does not have very good graphics hardware, then why don't you just replace what is lacking with software and use the hardware that is there?
I see.
For what that can do, then you don't lose any performance because you wouldn't have it anyway if you're writing to the lower level.
So that might be more of a question of should you even support the lower level feature levels then? If you're maybe we should follow up offline potentially. Up here.
Can you tell me the feature level of the Windows Phone?
I believe it's feature level 9.3, so 9.1 or 9.3. And I believe one of the other talks on the Windows Phone category talks a lot about that. Yep.
Windows RT has the GPU view.
Can you repeat the question?
Windows RT will have the GPU view.
There's actually a great talk tomorrow morning at 8:30 on performance with DirectX where he will be covering GPU view just a little bit. So the question was, will Windows RT support GPU view? I don't know, but maybe at 8:30 you can ask that same question and he'll know. So, any other questions? In the back? Right. So the question is, why isn't the DirectX control panel in Visual Studio? Well, that's the way it is, c'est la vie, I guess. I know that doesn't really answer your question, but that's just the way it is. Any other questions? Okay, thank you very much.